we done with this looking at the overview of our response data in our design. Now we want to analysis. So you go to analysis tab here, the analysis here, you click the filtration rate analysis tab. Okay, so you get this thing. We want to start to analyze. So analysis name, filtration rate. So here they said the linear regression, no transform. So you don't need to ni lah. This is just if what you call by default is no transform. If anything problematic with your model later on, you will see it in the diagnostic. But in this case, just select no transform lah as the start. And then how to start the analysis? Just go to start analysis, click that. Okay, click that. Okay. So you have this thing. Okay, this start. Wait. Okay. Okay, so the first thing you see here, you can see on the top here. Let me show you from the top. You can see there are configure, effect, ANOVA, diagnostic, model graph. Okay, configure is what? Configure is the one that we see before. And the analysis in this software, this design expert, they go from the left to right. So you start from here, and then next here, and then goes to ANOVA, goes to diagnostic, and then goes to model graph. So they already make in such a way that they are flow. So now after we press analysis, we get this effects tab, right? So if let's say here, normally when you do the what we call this analysis, you want to produce this ANOVA, the ANOVA table, the analysis of variance, because from ANOVA table you have this p-value and so on. So from that p-value, you know your model is significant or not, and then you can create your model regression analysis, and then you get the model. So that's the idea. But now if let's say I go straight to ANOVA, let's say I click the effect and I go straight to ANOVA, you will get the warning. Let's say I click they are warning. You have not selected any factors for the model. One thing about Factorial design is quite unique in such a way that you need to select the factor before you do the ANOVA. Okay, I repeat again. When you do RSM, when you do something else, for example RSM, response surface methodology, if you have experience in this thing, you don't need to select. You put the response, and then you click the what you call the analysis, you get straight away the ANOVA table. But for Factorial is a little bit different. A little bit different. So no, let me select no. Yes, proceed. No. Okay. So means that it bring back here. The reason for this is that when you want to sort of like to create ANOVA table, you need to have what we call the some replication within the design. If not, if you don't have any replication, then the ANOVA cannot calculate the F ratio. We learned about F ratio before. If you look here, let me go a little bit on the F ratio. We learned about this F ratio. Where is the F ratio? That's why we talked about the F ratio before. Where is the F ratio? Let me check. Statistic analysis. This is what? This is R. Wait for a minute. Okay, the F ratio. So F ratio is needed in order to do ANOVA. Normally you want to check between variation and within variation. We have learned about this before. The problem with Factorial, there are no between group variation, or there are no separation between these two. So the idea is that you need to sort of like give the software something at the bottom and something at the top, a group at the bottom and group at the top, so that the ANOVA can be created. If not, you cannot create ANOVA. That's why you get this error message before. You get this, you cannot proceed because there are no term is selected. Okay, so you need, in other words, you have what we call, in order to make ANOVA, you need to calculate the F value, and F value basically is some people say between group variation, within group variation. Some people say signal versus ratio. So it's basically the same thing lah. It's not the same thing. I mean that the convention lah. Some people say between group variation. Some people say this between group variation is called a signal. So that's some convention lah. But you need these two things. Okay, RSM. Okay, when you do the RSM, for example, RSM, something like RSM and so on, inside the RSM, they are already replicate. That's why you see when you perform the RSM. For those who never work with the RSM, just follow along lah. In RSM, when you put your factors and then you click the design, you will see some of the design will be the same replication. So because of that replication, then you can calculate this between group variation. You can sort of like you can calculate this thing lah. But for factorial, if you look at the design, if I go to the design here, actual, all design here, if you try to look carefully, there are no replication. They are the same thing. They are totally different with each other. Each design will be different with each other. Because of that thing, then the ANOVA cannot be done before you select the factors. So here, when we go to the analysis, before you go to ANOVA, you need to select something so that they can put the F value can be calculated lah. Okay. So normally the terms that is significant, okay, we have the term that is have high effect and low effect. So if you look here, the signal normally correspond to thing that what we call the term that is have high effect lah, because something that have high effect lah, large effect. This is low effect lah, low effect. So you want to select in such a way the term that is high effect is put above and the numerator, and then the low effect at the bottom, the denominator. So that's the software will do it for you lah. But now this is where you need to select. You need to select the thing. Okay. So this picture is half normal plot. We learned before normal plot, right? So here, if you look here, half normal. Side here, they are normal. They are cousin lah. These two things is cousin. So if you click normal, this is what we learned in the previous session lah. You can see here there are like the probability from 0 to 1000 to 100, and in the middle there are 50, and you see the what we call the scale is different. The scale is a little bit strange. It's not like a normal graph. It's like it's compressed in the middle like that, and they have tail in the side. So if you look from the side, you see like a distribution lah. So the idea is this: from the normal plot, you see if the thing is normal, if your result, this is response lah. If your the response is include all other stuff lah. I mean that the interaction and so on. So if all your response and effect on interaction is not your response, this is your effect lah. If the effect or the interaction all lies in the straight line, okay. So all lies in the straight line, then everything is normal lah. There are no abnormalities in the interaction or in the effects. But now you can see here there are something jumping off there, something jumping off here. Okay. Normally the easy way to see is to see half normal lah, because now you need to see the negative side. But you see half normal is the same thing but much clearer lah. Much clearer here. So you can see first there are two terms. One group of term in the cluster together on the red line. The red line here is we call it the error line. The red line is the error line. So it is placed in such a way that it represent the 50 the 50%, the smallest 50% of the effect. Okay, you see the line default to fit smallest 50% of the effect, meaning that you have the effect big and small. So the line will align in such a way that whatever on the line is smallest lah, is the one of the smallest effect lah. So this is the line, and also the effect you can see from the x-axis. So this is the effect 0, you know, there are no effect, and then goes to the right, you have larger and larger effect. Okay, so the color here signify whether it's positive or negative. Okay, you can see this positive effect mean that it contribute to the response favorably. Okay, for example, if you respond to increase the filtration rate, so positive effect contribute to that. Negative effect is the other way around lah. Okay, and how to select the effect? Okay, the most important thing here, before you go to ANOVA, you must select the effect. But which effect to select? So as you understand from this thing, from the concept here, you need to separate between the large effect and the low effect. So this software already make this half normal plot, make things easy lah for you. If not, you need to calculate and so on. So you can see here how to select is just click lah. Click. If you click here, the next also is what we call click. So then the on the right here, let me put here. On the right here is the Pareto chart. So this is Pareto chart. Okay. So the scale is t value. You will learn about the t value is basically just the what we call the scale lah, the different scale lah, t value scale. So if you click here, then you have this also Pareto chart click lah. If you click there, you click that thing lah. But if you like lazy, you just do like this lah. You just make a box and then everything will be clicked together. So from the Pareto chart, you can see the same thing, but at least you get the name lah. Temperature, AC. AC is basically what is C? C is concentration. So this is interaction. So now you know in your experiment there are effect of interaction. The AC, the temperature and also concentration. There are also interaction between AD. Okay, the temperature and also stir rate. And stir rate, concentration is the term that we use. The factor that we use. They also contribute some effect lah. Some effect on that. So if let's say I click this thing, the third one, the next one after the concentration, if I click there, mana nak click lambat je. Okay, you can see this effect is below the t value limit. Normally the guideline is that you don't take whatever below the black line lah. Okay, whatever below the black line, we say that is very very low probability that they have a good effect lah. So that's why they are below the what we call the black line. And also here you can see the Banfaroni limit. So if let's say the effect, your Pareto chart effect bar is beyond the Banfaroni limit, then it's most likely that it is what we call is very significant lah. If let's say your chart is in the middle, let's say the bar here in the middle, then you decide. You need to decide yourself whether you want to use that effect, you want to use that term, that thing, or not. Because remember, whatever you decide affect your ANOVA. And ANOVA is basically building the model for you. So whatever you decide here will affect whatever model that you get later on. So that's the important. The mistake that people do, that many students do, is that they what we call. Let me double click here first. Let me remove this first. Okay. So the mistake that many beginner did is that they select everything, which is not right lah. Because if you select everything first, it's not right lah. You need to separate between the large effect and the small effect. Okay, so this thing, the one that we not selected, will become like the residual lah, meaning that the lower effect you put in the denominator of the F value. Okay, so that's how you select the effect lah. Select the one that is jumping off lah, because the reason, the one I say you, the F value thing lah. And this you can also, if you want to go numeric, you can click there and then you can just read the thing lah. Okay, so that's one thing. So once you select the effect here, then only then you can go for ANOVA. Once you select the effect, if you click the ANOVA there, only then you get some value. So let me mean that you can go to ANOVA lah. I click that, and then I get this ANOVA table. Okay, so this is basically statistic lah. So we learned about p-value, f-value before. Okay, so if you look here, the first thing when you see the ANOVA table is that you look at p-value. P-value, as I said, is basically the what we call the tell you whether whatever you're finding, your hypothesis is significant or not. So here, if you look here, all model, all term that we select, you see here the model, under the model we have 1, 2, 3, 4, 5. Depending on the effect that we select before, you have 5. And if you look the residual is 10. Meaning that the rest lah, the rest that we not selected. Okay. Even though we have only 4 factors, but remember they are like interaction, so that's why they are more than 4. They are like 15 like that. Okay. So so you can see each term, we call it term lah ni, term. Each term here is significant. So the model also significant. The model here meaning what? Meaning that based on the result that you get, now the ANOVA will try to make a regression line. The one that we learned before, the regression line thing. Okay, so they want to make a prediction. So this is the model of for prediction lah. Okay, so you can see the model is significant. So you also have here f value. We see before the f value. So normally the f value and p value you look together lah, but you give more emphasis on p value lah. So for example, like here, the f value normally if higher is ni lah, is okay lah, means that there are some significant thing lah. If lower, then you need to check with the p value. Normally if the p value less than whatever you want, then it's okay lah. So this what we call here, you can see here all the p value by default. Okay, by default this design they put the p value by default at 0.05. You can see here, you have the annotation here. Here they give you all the good software, they help you lah. They have this p value less blah 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 and so on. If let's say you are expert and then this is like for you, you think like what we call, you sort of like remask, you are so like frustrated seeing all these things, you can just go to view and then just click remove the annotation. So yeah, if you ni lah. But if you want the help, not help mean that you want some annotation, just you click that and then you get this what we call annotation there. Okay, by default is 0.05 lah, meaning that below p value below 0.05, that is significant lah. If let's say you want to change the value, because as we learned before, this value you can change. You can put 0.01, you can put 0.1. It's up to you. I mean, it's up to your what you want. So you can change, go to edit, and then you get to preference. This just to show you, and go to the maths, whatever maths here. You can see here, this is significant threshold. By default is 0.05. The p value is 0.05. But you can always change lah. You can change here lah. You can change here, and then you, let's say you put 0.01, and then you okay. And then okay, it doesn't say anything, so that's why the careful also, because yeah, it's changed lah, it's changed here. So you see the p value less than 0.01, so it's already changed for you lah. But because our p value is very very low, then it doesn't affect, so it's still significant. Okay, so you want to change back, just go to edit and then preference, and then go to default. When you click default, everything go to normal. Back again lah. So you see the significant threshold, we go back to 0.05. So go to default, okay. Okay, so you can see here this change 0.05 again. So sometimes people change your, let's say you what you call, you borrow your the department, let's say you doing the experiment in your department or whatever, you share the computer, maybe some people change this without you knowing. So it's also good for you to check also at least this thing lah, because p value dictate what you want to get lah, the confidence that you want to get. Okay, So all p-values they pass our test, so that's good good thing. So for the further statistic, you can go to this fit statistic. You can see here they are fit statistic, and so this is just standard deviation for our regression model lah. So we have learned about R thing and so on. So the bottom line here is that just make sure the adjusted R and predicted R to be as high as possible lah. There are no cut off. There are no like how high is high, how low is low. There are no cut off for that. But the higher the better lah. So that's the key lah. So that is the just for the fit or the line, the regression line fit for the model. Okay. So what we call this here, they are coefficient. Coefficient meaning that, remember, you the ANOVA, when you perform the ANOVA and so on in this software, they will give you the equation. Okay, they give you the model equation to predict. Okay, remember we have learned about the model equation before this part. We have learned about this thing. I think this here. Where is the thing? I think here. Yeah, this thing. Okay, we have learned this thing before. So you can see when you make the prediction using the regression line, you have what we call the equation here. So this is the equation that the software made based on the data that you put lah after the analysis. So let's see again. So you see they are intercept and so on. So it's like a equation lah. So this coefficient means that this all the terms that you have lah. So if you look here, they are only 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 because we only select 5. Okay, so the equation doesn't need all the factor, because if you remember our design, if you go to design here, we have what? We have also the pressure. Go to summary lah. Summary is easy lah. You see, summary factors. You see there are 4 factors we use: temperature, pressure, concentration, and stir rate. But if we go to this what we call the analysis, you look at the equation, the model doesn't have pressure. It doesn't really matter because it doesn't need all the factors. It's just a model. Okay, so this is coordinate equation. So you see in the coordinate factor, you remember -1 and so on. So this actual equation, meaning that you use this equation. Let's say you have this and you put in the Excel. Okay, you put in the Excel, and then you put all these things, and then you change the temperature into whatever you like, and then you get the expected filtration rate. So that's the idea lah. Okay, so this like the normal equation. You put this, your temperature, your concentration. For example, you want to predict at that thing, and so on. So that is basically what we call the equation lah. This what does it mean? This is the regression equation that line that you get lah, the equation for that thing. Okay, so after this, after you done the analysis, meaning that the ANOVA done analysis for you actually. So after you done with the analysis, before you check the result, you need to check the diagnostic. So here there are diagnostic pane. The diagnostic tab here is, the idea is to validate the design, because the idea is this: your ANOVA might say is significant, but maybe maybe there are something wrong. Actually, you don't realize happening inside your during your experiment. So diagnostic tab, they basically they try to find, is there any problem with your experiment. For example, let's say if you do not randomize, and then you have some outliers happen, and then in the diagnostic tab you will see lah. So let's click on the diagnostic tab. Oh, so you see all this graph thing. Okay, so we start from here. So this is normal plot of residual. Remember what is residual? Okay, residual is this residual error, the residual, that thing, blah 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 thing, the residual. Okay, so that is residual. So basically the normal plot, you know about the normal plot before. The idea is that you want all your residual on the what we call on the straight line lah, on the sort of like in the straight line, because if it's follow the straight line, then it means that your residual follows the normality. It's normal. There are no abnormalities because everything, remember, everything is depend on standard curve, the standard normal distribution, that thing. So if let's say all your residual distributed nicely in the what we call in the line, straight line, then we can say it is what we call normal lah. It's normal. Okay. If you see there are some outliers here, that is a problem lah. What you can do is that you can take that, you remove that, and then you do model again. That what you can do lah. So in this case, that is look fine. So one way you want to people say that you can do the pencil test, mean that you take a pencil and then you put on that thing on the graph lah, on the graph. If let's say you don't see anything beyond the pencil, then it's good lah. You see the graph like that, right? You take pencil, you put on that red line. So if you don't see any what we call any point, any residual coming up from that thing, everything is hidden. Everything is hidden under the pencil, then you are good to go. So that's what people call pencil test lah. By default, this is externally studentized residual. So this studentized, this have something to do with the student T and the thing. But just to show you, is just the scale, the different scale. So by default, it's externally studentized residual. You can change by if you want to go to this residual only. Okay, you can change that. So it doesn't really have any difference. Okay, it's just the way how the scale is made lah. Okay, so you can see here they give you the warning. Students residual is recommended that just use what they want lah. External residual. Okay. Okay, so that is a normal plot with residual. Okay. So then we go to residual versus predicted. You know the prediction. What does it mean by prediction? The model itself. So the idea is this: you want your whatever data here scattered randomly. The random is it, the better. So that's the idea lah. Okay. If let's say you see something that is they are pattern, that is a problem. Okay. If there is some pattern, there are problem. You want it's randomly, your noise or whatever randomly distributed. That's the main idea lah. And also you want your whatever residual and this thing not beyond the red line here. Is you can view this red line as the confidence limit lah. If it's beyond the red line, then it's outliers. So what you do when you have outliers, you take that thing, you remove from the model. And then you run the model again, run the analysis, and then see, is there any new model which is significant? If there is, then it's better lah. Because you don't use the outliers. If let's say the outliers because of the experiment, it's okay. But if the outliers is because of your misconduct during the experiment, meaning that you make a mistake during the experiment, you will create the true outliers lah. So that will it will be manifested here. Okay. So and then you can see here residual versus run. Okay, one more thing is quite small, right? You can change this. If you look here, there are 1, 2, 3, 4. There are 4 page. You can click here lah, make it bigger. This is make it bigger lah. I make it bigger. So you see this thing. So what does it mean? Residual versus run. So now it's order based on the run. Remember, you have 16 run. You have 16 run. So you have 1, 2, 3, 16 run until 16 run. The run number. So here, if you have a trend going up or going down, that's a problem. You want the run will the residual for the run will be scattered like this, random. Okay, because if they are trend, for example, let's say they are trend going down here, they say something about your system. Your system is unstable, mean that there must be something happen during you doing the experiment. Okay, because maybe you are tired and so on, so your result is not good and whatever like that lah. That's why you don't do experiment in the last minute. Okay, you ni lah. So So that's the thing. So the idea is that make sure this thing not goes to beyond the red line, and also make sure it's random. Okay, the idea of the random, because when it's random, then the noise is sort of like distributed lah, the noise and predicted. Okay, one more thing. If I click this thing, the one that 4 here, if I click one, the rest also will be bolded lah. If I click one, if I click here, the rest also bold. So it's easy for you to check lah, to check here, where is this. So that's one thing lah. So if you want to remove one residue, you just remove lah. You just remove from the from the run. Okay, so and then residual Worcester factors, this nothing lah. This just make sure what we call they are like sort of like similar lah. Vertical line is, they are not much pattern, so you need to in such a way that the vertical this why they are two, let me make it bigger. Okay, this why they are left and right side, because you are working only on 2 level. So you see here temperature. So and this is the thing. So you have 2 things. So this only for the temperature. So you can change lah, residual versus whatever, pressure, whatever, and so on. So the idea is that you want this thing to be top and bottom lah, meaning that the vertical on the top, vertical on the bottom is more or less the same. Okay, you don't want like they are like what we call the very, they are pattern here like that. Okay, so let's go to this big one. Okay, now we done here, and then we go bottom here. So here is bokot. Okay, where is the thing? Bokot, where is the bokot? Here. Okay, so this bokot plot for power transformation. So this is to transform for the power law, for this lah, for the transform, meaning that like this. If let's say your data, your response is highly skewed, meaning that you have your response, you have 1, 2, 3, 4, and then suddenly you have 100, 200, 300, 400. So it's highly skewed, right? So when that happen, it will manifest here. It will suggest you to do some transform lah. So that's why you see the pH, the log transformation. The scale for the log is totally different, right, than normal scale. The normal scale you have like the one from one scale to another scale, from one point to another tick is the same. But when you use the log paper, so the scale is a little bit different. So some experiment they give the result like that, so it will manifest somehow here. But the idea here, if let's say the software here say that recommended transform is none, then okay lah. So the blue line here, we call it lambda lah. Lambda is our current transformation. Our current transformation is 1. So there are no transformation. That's the blue line lah. It symbolize the power applied to your response. So because we have no transform, so that's the thing lah. The green line here mean the ideal for what I call the best lambda value. Okay, lambda is just whatever this thing, but the best lambda value. Okay, so and the red line here is basically the sort of like 95% confidence that surrounding the thing lah. So long that your blue line, your current lambda is within this red probability, then you are good to go lah. So because now the blue is within the red, so that's why the software suggests no transform. Okay, so you are in the optimal zone lah. Okay, so let's go here. So now we have done here, and whatever predicted actual, whatever this thing. So you can just look around lah this thing, because I not discuss everything. So this also I will not discuss here everything, but yeah, it's just more advanced statistic, but enough for you. I mean, if you look here and you look here, you look residual versus run, residual versus factor, power. I mean, it's just enough to get already enough for sufficient for you to see whether your experiment problematic or not. So that's the thing lah. And then if you are like numbers, people who like numbers, you can just go to report and it give you everything lah. It give you everything there in term of detail lah, detail of everything.